Hi, my dear student friends. This is Guna, Assistant Professor. Today I would like to give small introduction about the applied physics. This applied physics is for circuitry branches. First of all, I would like to tell physics definition. Physics known earlier as natural philosophy. Physics derived from Greek word physico means nature. What is physics? Yes, it is the general analysis of nature conducted in order to understand how the universe behaves. Why is there interest in solid state physics? Yes, after the discovery of the transistor, there is a change exists in our universe. After that, our branches is also separated from the physics, like electronics, electronics and communication, computer science engineering, like that. In detail, we will discuss later about the solid state physics. Before that, what are the types of categories of people we have? The first category of the people, they can understand, they can enjoy the subject, they can reproduce that subject, they can apply wherever they want. That is the top category of the people. The second category of the people are they can understand the physics, they enjoy it, they reproduce. That means for the sake of the marks, they are studying the physics. But the final category, they don't understand the physics, but they can reproduce. I think you know how they are reproducing by heart. The good category is the first category. That means, first of all, you have to understand the physics. Whenever you understand the physics, definitely you can enjoy the physics, you can reproduce, and you can apply. That means, wherever you want, you can use this one, you will become a scientist like that. Importance of physics. Physics is all around us. From the moment you arise to the time you go to sleep, your activities, each and every activity involves physics. For example, when you cook your food, ironing your clothes, wash the dishes, listen to the radio, or answer your telephone call, or anything. In each and everywhere, the physics is exists. Physics means it is a natural philosophy. It is discussed about the matters and radiation. What are the kinds of matters exist? As we know that majorly three kinds we know, that is solid states, liquid state, gaseous state. But the matters exist in one more another state. That state is also called as plasma state. The physics involves in running automobiles, trains, orbiting satellites or communication systems, aeroplanes, zooming planes, each and everywhere we are using. That means as a transportation. For the transportation also we are using the physics. What is applied physics? That means why we have to study this physics. What is the difference between the physics and applied physics? Yeah, physics it has so many branches. Optics, mechanics, thermodynamics, like that. And that especially for us, we have to have lot of knowledge related to the quantum mechanics or solid state physics. Regarding that one, our curriculum has some topics. If you understand these concepts, that means the study of applied physics emphasizes the application of basic scientific principles to the design of equipment, which includes electronic and electromechanical systems for use in measurements, communication, and data acquisition also. First of all, we have to be learn physics principles. If you 100% understand and enjoy the physics principles, you can design whatever you want. So design means it gives the application. That means output. How to understand physics? Yeah, as I already told you, physics is around us. Suppose if I am speaking here, you are listening means there are some sound waves coming from my vocal cords reaches your ears. Now, how we can understand the physics is, first of all, as a physicist, to understand the physics, you should observe. You should observe. You can explain the concept. Then you can use that one. Then that is called as application. The basic principle for understanding physics is observation. Observation means experiment. Explanation. You have to say something about that experiment. That is also called as theory. Application. Achieving the desired object by using experiment and theory. That means whatever you want, you can achieve. Then when you understand the physics, then only. Experiment. We are going to the laboratory and we have some little bit of knowledge to do the experiment. So whatever the knowledge we have, that is called as input. That knowledge you are giving to the experimental arrangement, finally you can get the result, that is called as output. The output may be your expected value or your not wrong value. But that means it doesn't mean your experiment is failed. No. I tried in a different way. Our service to syllabus as designed based on the meters and also the radiations. How we can use these radiations and also the by using the meters, that is also called as applications. Now I will explain you unit wise syllabus, what are the topics we have, and by learning that units what we will learn. The first unit contains two concepts, interference and diffraction. These two consider the wave optics. As we know that there are two optics, ray optics and wave optics. Einstein said that the nature of the light is wave. In this, we can know properties of light, how it interacts with the matter, how can we change its properties depending on our requirement. Interference we are observing in our day-to-day life. For example, if you pour some oil drop on the water, we can observe multiple colors. That is due to the interference. Diffraction. The shadows are forming due to this diffraction. In the first chapter, we will be able to learn need of coherent sources and the conditions for sustaining interference. Analyze the difference between interference and diffraction with applications. Illustrate the resolving power. What is resolving power? The ability of an instrument to observe the things is an example of various instruments. Various instruments means microscope, telescope, like that. We will discuss. We will learn from the first unit. As a second unit, we have to be discuss about the quantum mechanics. Before quantum mechanics, that means quantum mechanics introduced at the end of the 18th century, that means 1895 around, and at the starting of 1900. Why it has introduced is there are some failures exist in the classical mechanics to overcome to explain the whatever the failures exist in the classical mechanics, the quantum mechanics is introduced. In this quantum mechanics, we will be able to explain the fundamental concepts of quantum mechanics, analyze the physical significance of the wave function, apply Schrodinger's wave equation, and energy values of a free particle. And free electron theory of metals. Also, we will discuss this. Free electron, the electron which is exists in the valence that can easily participate in the conduction. That electron is called as free electron. Why in the metals the conductivity is more? We will discuss in this free electron theory of metals. After that, we will discuss about the band theory of solids. In the band theory of solids, why some of the materials are good at conductivity and why some of them are not. That means in this, what are the bands, how they are forming, we will discuss in detail. We will be able to explain the various electronic theories, calculate the Fermi energy, analyze the physical significance of wave function, summarizes various types of solids based on band theory. Yes. Why is there interest in solid-state physics? Why? Because transistors, lasers, photodiodes, piezoelectric materials, superconductors, each and everything, the behavior of the materials to understand the solid-state physics is very, very important. After the discovery of the semiconductors, the technology is developing rapidly. Based on the band theory, they have classified the materials into three types: metals, semiconductors, and insulators. In the semiconductors, classify the energy bands of the semiconductors, intrinsic semiconductors and extrinsic semiconductors, and outline the properties of